Okay. So first of all, welcome everyone. So um, like what we are going to discuss for the next 1 week, right? So first of all, I'm going to give you more real-time scenarios, like what type of job roles available, and how to modify your resume with respect to the job roles and all. So those things we'll discuss, and I'll show you some advanced labs and some advanced topics we will discuss, right? And basically, our objective is to get the job into the networking. I can say okay, networking. So let me okay. So this is my screen. Okay. So computer network. So let's not wait further and jump into directly the queue. 1 second. Okay, computer network. So what is computer network? Connecting two and more than two computers, right? That is the computer networks. So if I go here, okay. So you can see here. So like you have multiple computers connected, right? So these computers are shared. They are going to the internet. They are taking the printers, right? Similarly, you can see here the computers are connected, laptop, tabs, your iPhones and all, and they have connected Wi-Fi, and from there they are going to internet. So connecting multiple things, what purpose? For sharing the data, for sharing the internet, for sharing the printer, for sharing purpose, we use the computer network, right? So this is our objective. So types of computer network, like I'm not going to go much in theory, but you know that LAN, MAN, and the WAN. So local area network, metropolitan area network, and WAN area network. So this one we can remove it. Why? Because it is not. No. So now only the LAN and the WAN. Okay, what is LAN? We will see that. So any network within a building. Okay, any network within a building, that is called LAN. This is one LAN. This is one LAN. This is one LAN, and every LAN will have a separate subnet. Subnet means you must aware about that. So every LAN is a separate subnet. What is WAN? Connecting multiple LANs is nothing but the WAN. Okay. What is internet? Internet is nothing but the example of the WAN. Like you have a Gmail account, right? Where is the Gmail? Gmail, it is in one of the server which is present in US or UK somewhere. So you're sending the data. Your emails are stored there. So you are connecting from the India. So that is mean one LAN to another LAN. You're connecting that, right? So LAN and WAN. So these are the broader categories. LAN. What is a LAN? LAN is nothing but, so here you will have a switch, okay, and you will connect all your machines, your laptops. So these are the wires, right? These are the cables. So we will talk about the cables also. Then your servers are connected here. You can see file server, mail server, printer server. Then your printer is also connected here. And similarly, from here you will have internet connectivity. So this is a LAN, and you know the LAN means you're one of the network will be like one network, 192 dot, let's say 168 dot 10 dot 0 slash 24. So this will be your network. So you will give them. So this is network is nothing but the family, and the host is nothing but this. These are the host. This is one host. This is two. Second host is third host. Like from the family, the same number will be given. 192.168, 10.1, 10.2, 10.3, 10.4, like this. So they are belongs to one family. That's why they are called as network. One network, and one network, single network is nothing but the LAN. Okay, so when you change the network, if you have another building, so there that will be the another network, LAN 2. So that will have a separate network, right? So we'll talk on, and connecting two different network, what we required a router there. We will talk on that in few minutes. Then metro will leave with the metro. WAN. What is WAN? So connecting multiple LANs. See, you have one LAN, let's say in Hyderabad, one LAN in LAN is nothing but one office, you can say. um, One office in Bangalore, one office in Mumbai, one office in Chennai, right? So you want to connect all them. Let's say Hyderabad is your what is called um, main office, head office, right? So you have all the files and all the servers are present here, Active Directory servers, your firewalls, all things are here. So these branch offices, they want to access this one, right? So you take a ISP connectivity here, here, and here. So generally we take for the WAN now. Most of the things replaced by the MPLS. MPLS technology. It is a like a L2 L3 WAN technology. So you it will be like extension of the LAN. You will be access over the public, but the ISP will give you direct cable. So you will just form a neighborship from this router, and here you will form a neighborship from this router. So the routes will be get replaced, and you will get connected to both LANs. So like this route WAN technology works. So WAN is nothing but the collection of LAN. If you have multiple offices, so you connected that is become WAN, right? So if you got a job in any MNC, so you will have one office in USA, one office in UK, one office in maybe Hong Kong, one office in maybe India. So you will have multiple offices connected there. So how you're going to connect that? So you must be having a service, something called either you will have a WAN connectivity, direct cable, L1 connectivity, L2 connectivity, or you will get some what is called nowadays the MPLS connectivity we get. So MPLS. So in India you will have like one ISP like Reliance Airtel. In UK you will have some another ISP. USA you have Verizon, you have Layer 3. Multiple ISPs are there. So what they do, they are to collaborate to each other. So in India, the Reliance they will provide you one cable to your office door, okay, and they will give you, okay, this is our IP addresses, okay. So what will happen? So they got interconnected over the worldwide, and the routes will be passed from here. Data will be passed from one ISP to another ISP, and finally it will reach to you. So they will charge you. So this UK ISP will charge you in your UK office, and India ISP will charge you in India office. So but the ultimate goal is these people can talk to each other. So that is called WAN. Next, so types of so LAN, peer to peer and client server. So peer to peer, we already discussed about this. So you have a like unmanaged switch. So you just connected multiple computers, okay, and you will form the work group, and it will get connected. So and the thing is here, in the peer to peer there is no control. So this guy can take a print, this guy can take internet, this guy can go anytime. So no control over here in the peer to peer network, okay. And in but in the server client is the best one. Why? Because and in organization you will see the server client network only. Where you will see the peer to peer, you will see this mostly in internet cafe, or in colleges, in hospitals, this type of labs where server based access is not there. Only like you will the computers will connect it and everyone will have any control. But peer to peer client server, it is required. So all will become a client, and this will become a servers. So how this they will become a server? Then in the same machine, it will be having some more hardware, and you will install a Microsoft or Linux or whatever the servers operating system. And what will happen? All these groups, these computers, they will join the domain. Okay, there will be one domain, and this will be joining the domain, okay. And from here you will control everything. Like, okay, this person can come this time and he can log in this time, he can log off. So the same user ID can be, he can sit here, he can sit here, he can sit here. Okay, this person cannot access the internet, this person cannot take the printer, this person cannot access this particular share drive. So these all controls you can have in the client server. So for this what we use a servers. That's why the server operating system need to be learned that, okay. So network topology, like in the network we will have a bus topology, ring topology, mesh topology, the but the best one is which is used, this is the star topology. Okay, what is the star topology? So in the star topology, it is like you will use a central access device. Okay, this is called a central access device. So every computer will from one you will have a LAN port here. So from here you will connect it to the switch port. So like this, every computer will connect here, and this guy will become a central management tool. Okay, so it can be switch, it can be router, it can be hub, right? So mostly in the switch you will see multiple cable, multiple ports. Okay, so now if you see here in the network, what are the types, what are the like things you are seeing here? The first thing, you are seeing a computers here, right? Second, you are seeing a cable, which is very important. And third, you are seeing a central access device here, right? So three things. A network become a combination of three different things. So if you miss anything, then you will your network will not be visible. You will not be having a network, right? So this all computers are get connected. So now the question is, if you want to make any LAN, so what is your requirement? Okay, so let's build a LAN. So what is your requirement? The first thing, computers with the NIC card. So you must have a computer, okay, with a NIC card. NIC card means there will be a LAN port will be available, that is called a NIC card. But nowadays it will be you will have any laptop, any computer with a NIC card, and every machine will have a one NIC card. Okay, but in some heavy servers and all, they will have a multiple NIC card. And one NIC card, you can connect to one cable, RJ45 cable, and you can assign IP address to that particular NIC card. Okay, you need a NIC card. Then you need a power. Without power, nothing will work. RJ45 connector. RJ45 connector, we will see in for a few minutes. RJ45 connector, you will have something like this. So it will be with come with the cable and copper cable. Copper cable is required for that. Without cabling, how you will do the net? Then you required a central access device, a switch or hub, and finally, okay. Now what will happen? What happen? You okay? You understand that I have these four computers, okay, and I got the switch, I got the cable, and I connected them all. Okay, now I become a network. So how can I share the data? No, without IP address. How IP address is nothing but the names. Okay, this is Riaz. Okay, this is Usman. This is Nadeem. This is like Ubedullah. Okay, so these are the names given. So I can talk to them. When I say Usman, so Usman will reply me, right? So similarly, the in the machines in the networking world, every machine should have some names. So there are two types of names. We will talk on that. So one is a physical name, and one will be the logical name. Okay, physical name is nothing but the MAC address. Every machine will be identified with the MAC address. Okay, MAC address. And every and there will be one more name, logical name. Logical nothing is nothing but the IP address. Okay, every machine should have a IP address to talk to each other. So these are the LAN requirements. So now you got this all LAN requirement. So now what next? Okay, so now OSI layer. See, the networking, networking is work on the OSI layer, Open System Interconnected Data Model. So this OSI layer, it will be like every these are the layers, 7 layers are there. Every layer is having its own function. So when I say one computer, it is talking to another computer. Talking means what? You are sharing the data, you are like you are copying the data, uploading data, something to each other, like they are talking to each other. So when they talk to each other, the OSI 7 layers are work behind that network. If you understand those 7 layers, then networking is in your pocket. Okay, and and every layer, there are different devices work on every layer. Okay, that is what my point today, which I need to discuss on layer one. See, I'm not going to tell much in theory. So what are the TCP/IP sorry OSI layer? So first is the physical layer, data link layer, network layer, transport layer, session layer, presentation and application layer. Physical layer, all your cables will work on the physical layer. Okay, in the cable you have two types of cable: copper cable and fiber cable. Okay, copper cable and fiber cable. What is copper cable? It is used for the smaller distance, RJ45, which generally we see in the in our labs. And fiber cable, it is used for the longer distance, right? Now you connected the cables in the physical layer. Bits, the traffic will go in types of in the form of bits. Then you have a data link layer. Data link layer is nothing but the MAC addresses. So your switches, okay, switches layer 2, this is called a layer 2, this is called a layer 1, this is layer 1. Okay, layer 1, this is L2. So your switches are working on the data link layer. So what the switch does? Switch does MAC addresses. They store the MAC addresses. Then third layer is a network layer. Network layer is very important one. So your routers work on the network layer, right? So here in the switch, send the packets in the bits in the form of frames, and now in the network layer, it become a packets. So the packet got sent. So routers now here the IP address will get understand. So the understand like this: cables, then the MAC address, and the IP address, right? So these are the three layers you got, and you have a switch and you have a router. Switch work on layer 2 and router work on layer 3. Okay, and your cables are work on the layer 1. Then the transport layer, end-to-end connection reliability segments. So your TCP IP and ports are work on here. So it will be like a transport. It work from this place to this place. The source to destination, it transfer the data. So layer 4, this is called a layer 4. Okay, so you have a firewalls like port-based firewall like Cisco ASA or Juniper port-based firewall. So these firewalls work on the port-based firewall. Okay. Then finally, what will happen? This top three layers. Okay, this top three layers, application, presentation, session. So they form a data in the form of, let's say, from this side you're sending one photo. Okay, one photo. So finally, the it will get a photo. You will see the photo in this place. So the session host communication, then presentation, encryption, decryption will happen, and finally application will see here, application process, and you will see the image here, right? So media, and if you see here, these are our network layer. If you are working in the networking, so this four layers, okay, I mean network and security. So you guys need to be worried about this one, these four layers: cables, switch, routers, and the firewalls. And if you are working on the some next generation firewall, okay, like a Palo Alto or Checkpoint or what is called Fortinet, ASA, Firepower. So those things, so those are working on the layer 7 firewalls. Those are layer 7 firewalls. Okay. So, but from the core network, when I say network, so you need to concern about these three things: bits, frames, and packets. Okay, MAC IP. So see, our entire networking is depend on MAC IP ARP. So I'm going to show you then in few minutes. So physical layer, data link layer. So you can go through with you already know about this physical layer, data link layer. So how the data goes, can you see here? Clearly mentioned. Okay, the physical layer means your cable. This is a fiber cable, this is a copper cable. Data link layer, your switch is here. Network layer, your router is here. Transport layer, it will transport the reliability and it will send the data. Okay, session is it get the bridge. Okay, and encryption decryption will happen in presentation, and finally you will see this page. See, the OSI layer work behind the network. OSI layer is work behind the network. So our entire networking is depend on here. Okay, so you need to go like this. So each layer is having a different functionality. Each layer is having a different network, different devices. That's why you need to learn these all things. Okay, then it become TCP/IP model. So it become a shortness. So in TCP/IP, what is the difference in TCP/IP? The network layer, the top network layer, internet layer, like the first two, physical and data link layer become a network layer. Then internet layer, it is a layer 3 layer, and transport layer, it is the same. And top three, application session and presentation will become application layer. So like this, now TCP/IP have the four layers only. Okay, so network layer, internet layer, transport layer, and application layer. So how they work is like a physical layer and data link layer. So again, this one in the network layer, your ICMP, your ARP, IP addresses, this will work. And when the data transfer, so data can be transferred by a TCP or UDP protocol, transmission control protocol, user datagram protocol. And finally, you will have application SMTP, FTP, Telnet, DNS, whatever the applications you have. So see now TCP/IP, it's short. This all three layer called as application layer. Okay, then you have a transport layer, the network layer, and these two become okay. This is called internet layer, and this will become network layer. Okay, so TCP/IP model. So our entire network is depend here. Can you see here? See, when I say a physical layer means the cable to cable transmission, then the MAC, then the IP, then the remote host, and finally the data will see here. Okay, now let's talk about the NIC. So I'm going from bottom to top. Okay, before that, I just need to make sure that people are not sleeping and they are awake. Yeah, they are awake. So Riaz, you still wake up?
Yeah. Yes. I'm in the class.
Okay. Good. Usman Ali, क्या मीटिंग ज्वाइन करके भाग गए क्या?
सर
या
ये एनवायरनमेंट जो आप अभी समझा रहे हैं सबके लिए, तो ये उनके लिए जो फ्रेशर्स है उनके लिए है ना?
ये हर एक के
जो
लिए है.
फ्रेशर्स
ये हर एक के लिए है.
ठीक है
ठीक है.
क्योंकि
ये नेटवर्किंग का
नेटवर्किंग
मग्ज है ये. ओके.
हाँ
सो प्लीज गो ऑन म्यूट. या ओके. Okay, so NIC card. So you need a NIC card. See, okay. So these are the NIC cards. So you will have RJ45 cable. So you can see here. See, this is RJ45 cable, and this is the copper cable. Okay, and this is also a revision class. Okay, so if you already completed this one, and if you see this is you already covered, so please leave the class. So this is not compulsory. Okay. And this is called a LAN card. So your computers will be connected here. You will have this LAN card. So this RJ45 and this copper. So your layer one is this one. Okay. So in the system you will see this one. So this is your LAN card. So without connecting this cable, so most of the issue will be with the LAN card, like network issue, the layer one issue when we say, so the LAN is connected or not. And every NIC card, this is called a NIC card. Every NIC card will have one MAC address. MAC address will get associated with the NIC card. So you will have a NIC card here. Okay. Next is cables. So when we talk about the cables, so these are multiple cables. So let's not go, don't get confused. So I will just give you a very simple example. Two cables. One is a copper cable. Okay, one is a copper cable. This is which is this one, which will have a 7 layers, 8 combination of the cables. So nowadays you no need to do the crimping and all. So if you go and just buy a cable like cat6, cat7, so these are the latest one. Okay, cat6, so you will get 100 mbps speed. So generally we use in all the LAN, so these are the copper cable we use. And when you have a long distance, like more than 10 meter, 1 kilometer, something like that. So you like in that duration, so copper cable will not work. So you need to use a fiber cable. So for the fiber cable, it will be look like, so in the data will go in the form of the lights in the fiber cable, and this is called SFP. So if SFP will be used to connect on the switches, and this SFP it covered like convert fiber to copper. So you connect for the long distance we use the fiber cables. Okay, and for the short distance we use copper cable. So two cables, you can understand. Then types of communication, we have unicast, broadcast, and multicast. Unicast is only one person is sending something. So when you say, see, MAC address and IP address, MAC address, IP address, so these are very important. So when you say unicast, So can you see here the source is sending the data. So source is sending data to specific destination. Can you see the MAC address is known and the IP address is known. So this is called a unicast. Okay. And when we say broadcast, so you can see this guy, he don't know the MAC address. So that's why he is sending FFF, 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 FFF. So it is nothing but any. So what will happen? So it will broadcast to everyone. Okay. IP he know, but he is looking for the broadcast. So this is the another communication. And third is a multicast. Multicast is nothing but the specific MAC address with the specific public IP address. Sorry, public specific IP address. Like multicast means you must heard about like in OSPF the data transfer in multicast address, and the routing in the RIP version 2, the routing is again a transfer with the multicast address. So multicast address means special like out of this four, the traffic will only go to these two. Why? Because they are multicast. Multicast is specific to the subnet. Okay, now, so now we understand the layer one. Layer one is nothing but the cables. In the cables, you have a, copper cable and the fiber cable, right? So now we are moving towards the switches. So what is switch? Switch is, see, you connect, you have layer one, you have a cables. Okay, cable is done. So now we are moving towards the switch. Okay, what is switch? So because your network is depend on this one, you got the cables. Now you are connecting to the switches. Okay, what is switch is a layer 2 device, and they work on the data link layer. Okay, switch learn MAC addresses. Remember MAC addresses. MAC address is nothing but the physical address. Every NIC card, every computer, every network machine in the world, they will have a MAC address, unique identity. So switch identify that unique identity. Okay, and switches are intelligent devices. Intelligent means they have a brain. So they store they maintain the CAM table, MAC addresses. Okay, they have a CAM table, content addressable memory. They maintain the MAC addresses. And switched and what switch? Switch is a layer 2 device. It learns the MAC address. And what it does? Switch does the switching. What is switching? Forwarding of frames from one port to another port. That is only the work of switch. So you will see the switch here. So you will have a computer here, you will have a computer here, you will have computer here. Okay, so these computers are connected. So what switch does? So switch store the MAC address. It will have a brain that is called a CAM table. Okay, CAM table. So when you say show MAC addresses, that command, so you will see, okay, on my port 1, MAC address A is connected. On my port 2, MAC address B is connected. So the switch understands. So this is the brilliant. So it is called intelligent. So he understands which port, which who is connected. And what it does switching, forwarding a frame from one port to another port, forwarding a frame one port to another port. That is only the work of switch. That's it. What does switch do? Switch does, you just need to connect the cables. Okay, from one computer or printer, your laptop, your wireless device or whatever it is. So cable you connected here, so immediately the switch will capture its MAC address. Okay, and it does a switching. And switch has some topics like VLAN, VTP, STP, ether channel. So those things will be covered in the switching things, right? But the main function of the switch is to learn the MAC address, right? Similarly, now you will see the MAC address, physical address. What is the MAC address? When I say the MAC address, so media access control. So you will see this. So you know the it will be the MAC address. It will be 48 bit. I think, yeah, 48 bit. So 24 bit. It will be organization unique identity, and the next 24 bit will be network interface control. So if you go for Cisco, so Cisco, all devices will have this 3 octet will be common. Microsoft will have a 3 octet common. Dell will have a 3 octet common. So these three are identified, and these three will be different in every machine. Okay, so MAC address, it is controlled like this. So in the switch, when you say show MAC address, I will show you in the lab. When you say show MAC address, so it will tell you, okay, this particular MAC address is connected on my this interface. This particular MAC address connected into my interface. Okay, so this is how the switch learn. And in a computer, if you want to see, just go and do ipconfig/all. Okay, so you will see something like this physical address. So it will be like this. So this is a 64-bit physical address. Sorry, a 48-bit so physical address. So MAC address, it is okay. You cannot change the MAC address. MAC address is the fixed one. Okay, so that's why the physical address, see, your networking will be, you need to deal with the MAC address and the IP address. Okay, MAC address is done. Now the IP address is a logical address. Okay, logical address, again, these IP addresses are owned by the IENA. Okay, so these are the national international organizations, so they own that. So every IP address, so IP address, the range is 0 to 255 only. Okay, so and every your IP address will be defined in 4 octet. 1 octet, this is called 1 octet, second octet, third octet, fourth octet. So IP version 4 we are using. So it has another version also, IP version 6. So IP version 4, it is having it is a 32-bit IP address. So it will be sorry, not so 8-bit, 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 sorry, 24-bit. See, I got some. I'm going some speed, so that's why. Okay, so 8-bit, 8 octet, one of first octet, second octet, third octet, fourth octet. So the IP address is required. Okay, IP address to communicate in the network, right? So INA, what they did is they defined the IP address in the classes: class A, class B, class C, class B, and class E. Okay, so class A, so this is the range from anything which start from the 1. If you see the IP address is the first octet is a 1, it means a class A. Okay, but when you say this particular IP address 192, so 192, it is from the which class? So you will see here the 192 is nothing but the class C. Okay, because it start from this one. If any IP address like say 200, 200 dot something, see the first octet, you will see which class it is. Okay, so these are the classes. And class D and A, this is the reserve, you cannot use this one. So you have this one ABC, and every IP is like a perm, like you need to buy the public IP addresses. So what the IANA did is, say they make few IP addresses free, like a class from class A, class B, and class C. So three ranges they gave for free access. Rest every IP address you need to purchase from the ISP. Okay, so you will see it. So public IP and private. So these are the ranges they gave free. Private IP address 10.172 and 192. So you will see these IP addresses used in your LAN. Okay, they are not charged. But apart from this, if you buy, if you want to use this one, 1.11 dot something, 128, 129, 192.160, so anything, it will be charged. Okay, so for the public and the private. And how to see the IP address? Just say IP config, so you will see this particular IP address. So this is nothing but your IP address. Physical address is the MAC address, and logical address is the IP address, right? And why the public IP is, and two types of IP addresses: private address, which we use in our LAN, and public IP address when your LAN want to go to internet, then public IP address. Okay, so if you want to go to internet, so and in your browser, you just go and check what is my public IP address. So if you connected to the Wi-Fi, you must be having a public IP address. Why? Because private IP addresses are not allowed on the internet. Okay, as per the RFC rule, private IP address. So what are the private IP address? These are the private IP addresses. They are not allowed on the internet. Your ISP will block that. Okay, and if you want to go to internet, then you need a NATing. Okay, network address translation. Okay, so NAT is required there. Then okay, so in the network again, it is defined. You understand the network and the host. Okay, so network is nothing but a family. Okay, family, and in that family, this is the host, this is the host, this is the host. Okay, so these are the host IP addresses. And then IP addresses detail, like again, few things like IP class A, class B, class C. There is a subnetting. It's a big chapter, so you need to do some study on that. This, like class A, class B, class C, and in class A, how many what is called in class A, you can have a more you can make more host. Okay, and in class C, you can make more networks. Okay, so host bit and the network bits. So your IP addresses will be classified into the host bit and the network bits. Okay, and the subnet mask is defined by define the which subnet it is, like slash 24 class A, class C, slash 16 it is class B, and slash 8 is a class A. Okay, when I say 24 means the first three octet 25.25.25.0. So first three octets are same. Okay, that and the host are defined in the fourth octet. So that's this one. Okay, so IP address versus with the MAC address. So see, this is our ARP. When we say the ARP entry, address resolution protocol. So the switch or your layer 3 device, they for communication from one switch to one device to another device, you need a ARP. Okay, so ARP is nothing but the resolving the MAC to the IP. So your layer 3 device should know what is the MAC address and what is the IP address of that particular machine. Okay, so you will see every machine, as I said, this is the its logical address, this is its physical address, logical address, physical address. So ARP is required there. So IP versus MAC. So IP address again, IP address is the logical address, MAC address is physical address. It can be changed, it cannot be changed. Okay, it is defined by you, it is defined by organization. So remember, you need to play with IP address and the MAC address in your real time. Okay, so this is how the ARP address resolution protocol. So it learn the MAC address. Okay, if you know the IP, so it will try to look for the ARP, and the reverse ARP is the reverse of the ARP. So IP to name. So some important tools: ping, traceroute, and then NS lookup. You must know about this one. See, this is our day-to-day bread and butter. Okay, ping means is the network is allowed or not? It is pingable or not? So you can see here. So you're having some google.com, ping google.com. So you are getting the reply. It means the google.com that destination is reachable. Okay, when you say a traceroute, see, I'm doing it from my machine. When you say a traceroute, so you will see like how many hops are coming from between you to the Google machine. See how many hops are coming. So these are bread and butter. And the NS lookup, when you say, let's say NS lookup bbc.co.uk, so you will see this particular IP address. It is when you say NS lookup, so it will give you the what is the DNS server. Okay, what is the DNS server? DNS name. DNS is nothing but IP to name. You cannot remember the Google IP address like 222.214.58.214. So instead of that, human tendency is you remember the google.com, right? So the DNS is the service it does on the again servers. DNS is the service, so it make a name to IP address, right? Next, okay. So now we understand for the networking you need a cable. Okay, you need the layer 1 cables, then you need a layer 2 switches. Okay, then after that you must be required routers and all. Okay, so now in this why we are learning the Cisco. Okay, why don't we learn another like Cisco? The switches are made by Barracuda, Juniper, HP, Siemens, Avaya. So many vendors are there. Why the Cisco? Because in the generally when we say the routing switches and also Cisco is the leader. Okay, they are having the 90% of the market, so you will, that's why we are learning. But if you learn the Cisco, so even you can manage the another stuff also, Juniper also. So some commands will be different. You will see the same technology, like you will be having VLAN, you will be having trunk, you will be having um, ether channel bundling and all. You will see all this technology, but some different command. You can just go if you get the Juniper switch, so don't be like um, oh, I don't know Juniper. No, just go Google how to create VLAN on the Juniper. So you will get see the command. Just put the command. So don't worry about that. So if you learn any, that's why we are focusing on the Cisco, right? So Cisco router and switches. Okay, so now you will have a router versus switches. So what is the router? Router is the layer 3 device and it does the routing. Okay, like switch is a layer 2 device, it does the switching. So router is a layer 3 device which work on the network layer, and it does the routing. Routing means what? Connecting one network to another network. So the best thing is you have one LAN here, LAN 1, and you have LAN 2, another office or maybe another building. So, and both are different network. This is one network, this is one network. So you want to connect two different families, then you need a router here. Okay, so switches are used within a LAN, right? So you're connecting two different LAN, so you need a router. Router, it does a routing, it forwarding of packets from one network to another network. And what is the switch? Switch, it forward the frames from one port to another port, and router does a routing. See, layer 2 and layer 3, try to understand this one. And how we connect to the router on switches. So you will have a console cable is this one. Okay, router, so you just connect to your computer console, power on your switch or router, and use the putty, and use the you will have this console cable, and just use putty, and you can start configuring the switch and router. So switches, again, like when we talk about the switches, so you will have a mode, user mode, then enable mode, and you will have config terminal mode, and you will have this mode. So in each mode you can do some access. Okay, like user mode and enable mode. If you want to configure anything in the switch, you need to go to in the switch. Okay, in the Cisco, is it maintain the iOS, Internet Operating System. Okay, Cisco is having iOS called Internet Operating System. So in this, the Cisco has its own operating system. Okay, iOS. So it will come with the, when you buy a switch and router, it will be there. So in the router and switches, so there will be something called flash memory. So iOS will be built there. When you power on, so automatically that iOS will come to its running configuration. Okay, and you can start booting the switch into this one. So uh, okay, so for this one. So guys, how to do the like practice? Okay, so I have 5-10 minutes. So tomorrow we will just focus on this thing. So but today I just want to show you. So this is the packet tracer. So packet tracer is install it. It is you can do the entire networking here. So you can right now it is 6.3. So you can buy 7 dot version also available there. So you can go, and it is a free install, you can just buy it. So you will have in all the networks. So you can see the router, switches, servers are there, cables are here. So let's say I'm taking here, this is the switch. Okay, I connected the switch, and you will see the end device. Let's say you want to connect, you are making a LAN. So this is one computer here, one computer here connected. And what you want a cable. Okay, so cable means you can take a copper straight or copper cross. So straight cable we use from one computer, so it will ask which cable. So first Ethernet from here to which port of the switch. Let's say this port I'm connecting, and here also which port from here, which port of the switch I'm connecting, this switch, this one. So you will see this one. So now if I go to the machine, okay, if I'm in the machine. So let me just give one IP address to this guy. Let's say 192.168.10.1. Okay, so you will see the subnet mask will be given automatically here. So I have given this IP address, and now next one is the desktop. I'm giving this IP address to another machine, 192.168.10.2. Okay, and when I say tab, so automatically the subnet. So class, this is a class C IP address I have given. So now if I go to this machine, okay, and can I ping to this guy? Okay, can I first of all let me see my IP config. So can you see it is showing, okay, this is your IP address and this is your physical IP address, your MAC address. Okay, so can I ping to that guy 192.168.10.2? Yes, I can ping that. Okay, so I can ping that. And how it possible? It is happened with the centralized device. So can you go to the switch here? So I just go to the switch, CLI. So now this is the switch. See, by default it will the name will be switch. So we are in the user mode. So you just need to say enable. So now you're into the like no, now you are in enable mode. So here if you say show MAC address table. Okay, so let me go and ping here also from ping. 192.168.10.1 from this machine. Okay, I'm able to ping this one also. So if I go to the switch, can you see this? So switch learn the MAC address. See, it is saying port 1, B4 C4. So this MAC address is connected. And port 1, port 2, this MAC address is connected. So switch does switching. Okay, it's doing the switch. Like tomorrow, if you're connecting another switch, okay, if you're connecting another machine, okay, so you connect here, just from here, you just need to connect this one. And if I give the another IP address, the name, like let's say 192.168.10.3, okay, 10.3, just go here. So can you see this? So tomorrow we will just focus on the lab. So tomorrow I'm going to take all the switching labs. Okay, so in the switching, what are labs we have? So see, this is a like I'm not going to take everything in single one. Can you someone go on mute?
Sir, I have a doubt. Sir, I have a doubt
Can
on enable window where we have type of command. So enable show the back table on that window. On that window. Yeah, on this window, on the
yeah.
first line, first table, we didn't get any information of, when we type the command. Then on the second time when we type the command, we get the details. How it is?
Mhm. Okay,
See,
so
Mac and
switch learn the MAC address. So
okay.
you need some type of traffic there. So I generated some traffic, so switch understand this thing. Okay, so okay, so we have in the switching. Okay, here. So see, our switching chapters are defined like this. Like what in the switching we have. So you will have a VLAN. Okay, you will have a trunk. Okay, trunk. Then you will have a what is called STP, spanning tree protocol. Then you will have a ether channel. Okay, and the fifth one you will have HSRP and redundancy. HSRP and all. So if you go CCNA switching or CCNP switching, so your entire things will be dependent on this one only. And you know what? They all are dependent to each other. VLAN, trunk, STP, VTP. Sorry, I forget one more thing. VTP. VTP is like this one. VTP also. So VTP, STP, Ether channel. So you need to remember. So your entire switching is dependent on these seven topics. So even CCNA, CCNP, or CCI level, you will see these topics only, and your interview will be depend on this one only. So tomorrow we are going to cover the switching labs. Okay. So in one diagram, I will show you all the VLAN trunk. So you like VLAN trunk, VTP, STP, how it does, and how the network will be built, and in the networking how this technology will be used. So we will inshallah will try to cover that, and it will be a summarize, like you will see a real time. I will also show you that in the real time how the switches will be connected, and the network diagrams, how the network diagram will be look like and all. So we'll inshallah will try to see that. So jazakallah. So today I'm going to stop here. So tomorrow we'll continue in the same time inshallah.